Before we go on to look at how we can build filters in the digital domain, I think it's important for us to understand a little bit uh, more some details about digital signals. Okay, uh, let's start doing that with this video. So if you have an analog signal, as I've shown here, and let's say you take this analog signal and you sample it, right? Uh, and let's say you use a particular sampling frequency, and the corresponding sampling interval is given by TS1. Now, what you do with this sampling interval is you sample the signal and you get these values, which are marked as dots on the signal. Once you sample this signal, what do you have in the digital domain? What you have is an array of numbers, right? So that array of numbers is given by, let's say, this array. Now consider the sampling of another signal which has the same shape, but it is compressed in time. Okay, and even though it's compressed in time, we can have the same samples, the exactly the same values as we had here, if we use a different sampling time, which is divided by the same factor by which the time is compressed here, right? So let's say if the signal here is twice as fast, then if we reduce the time period by half, you should get exactly the same digital signal as you had before. So what I'm saying is sampling this signal with a sampling rate of TS1 and sampling this signal with a sampling rate of TS2 gives exactly the same digital signal. Of course, they are not exactly the same digital signal if we know at what sampling frequency they have been sampled. So this one has been sampled at a different frequency than this one has. Now, if you include that information, then the digital signals become different. But when you have it in the digital domain, you may have the sampling frequency stored at some place, but really you're only dealing with that array of numbers, right? And as long as we have only that array of numbers, this signal in the digital domain and this signal in the digital domain look exactly the same.